Okay, so section 3.2 is on finance. I'm just making on compound interest. I wanted to make sure I was actually recording here. So we are going to learn how to solve compound interest problems. And we've seen it before, but here it is again, the compound interest or exponential growth formula, where A is the amount after t years, P is the principal, or starting amount, R is the interest rate in decimal form, T is time in years, N is the number of compounding periods in 1 year, daily, monthly, quarterly, etc. So for these and future formulas to come, it's important to know what these words mean. So annually means one time a year, once per year. Biannually, twice a year. It might also be called semi-annually. Quarterly is 4 times a year. Monthly is 12 times a year. And daily could be, well, it's 365 days in a year, but you have to look out because if the problem specifies the banker's rule, then you're going to use 360. So the banker's rule is because back before the computers used to exist, people had to manually compute all these things. So computations were simpler with 360 than they were with 365. So banks all over the globe adopted 360 days in a year instead of 365. And it didn't make much difference in the calculations. So you're encouraged to use your compound interest portion of the spreadsheet, but if you're trying to find principal, rate, time, then you need to solve it by hand. So I believe we'll be doing one of those in these examples. All right, so for example number 1, part A, you deposit $400 in an account earning 6% interest compounded annually. How much will you have in the account in 15 years? So I'm just going to highlight all the important information here, and it's annually. So since I am trying to find future value, I can go ahead and just put these numbers in the spreadsheet, and it's going to tell me that the future value, or how much I'm going to have after 15 years, is the $958.62. So it's really easy. You just type the information in. Of course, you have to know what is what. So there's a little bit of learning curve there, but once you get used to it, it's pretty easy. So part B, you deposit $4,000 in an account earning 8% interest compounded monthly. How much interest will you earn after 5 years? So again, we're going to highlight all the important information, plug it into the spreadsheet, which I have done, and I have a screenshot here for you. You'll notice that it says never put anything in here. We never put anything in the payments section, but it's used in the final formula, so that's why it has to be there, but you just ignore it. So I put the $4,000 in for present value, 8% for interest rate, 5 years, and it's compounded monthly, so that's 12 times a year. And this time it wants to know how much interest you're going to earn. So it's not the future value we want, it's the interest. So just be careful because there's 2 answers for each problem, and you got to make sure you give the system, the homework system or the test problem, the correct answer. And sometimes you're putting both in. Okay, so example 2, you're saving money for tuition. So new parents want to open an account to save money for their newborn child's college tuition about 18 years from now. According to the Department of Education, as reported in the U.S. News and World Report, the total cost for a 4-year degree at a public institution in the year 2030 will be approximately $205,000. The parents know that the child could lower the cost by attending community college and also expect the child to contribute some through part-time job, student loans, etc. Therefore, their goal is to save Oh, I thought I had a highlighter. 120,000. It's 7% compounded quarterly. How much would they need to deposit to reach the goal in 18 years? So this one, we're not finding the future value or the interest accumulated, so we have to use the formula. So I'm going to write the pertinent information over here. I know that T is 18 years. Future value is 120,000. The rate is 0.07 as a decimal, and the compounding periods are quarterly, so that's 4 times a year. Our formula is A equals P, parentheses 1 plus R over N, close parentheses to the NT. So plugging in the information I have what we want in the end. We want 120,000. What we're trying to figure out is how much we should put in, which is P. And then the rest of the information we have, and I can plug into the formula. And then we have to solve it for P. Be very careful with these. The place where students get this wrong 9 times out of 10 is not putting the exponent in parentheses. So when you put it in a calculator, you would type parentheses 1 plus 0.07 divided by 4, and then raise to the parentheses 4 times 18. That's how you would do it in a calculator. Some calculators have an exponent that actually goes up into the exponent and stays there until you go out. But this will work no matter what calculator you're using. So after I press enter on the calculator, it tells me that that part of it is 1.0175, and that it's raised to the 72 power. Actually, I haven't completely computed it yet. So if we just do the inside of the parentheses first and then do the exponent. So if you went ahead and did the calculator part, then you probably got 3.48721. So just be careful here. It's actually probably safer. So we know we need to divide by that to solve for P, right? However, I'm rounding. There were more decimals there than I wrote down. And if you round before the end, it's going to throw your answers off. So it's better in the calculator to do it this way, 120,000 divided by, and then put the whole thing in. Actually, we're going to need 2 sets of parentheses. I'll put them in a different color here in a moment. Well, we know it's 72, so I'll just do 72. And then just to highlight that there's 2 sets of parentheses here. So all I did was, instead of calculating what this 1 plus 0.07 divided by 4 to the 72 power is, and then using a rounded version of that answer, I'm just putting the whole thing in. So P is actually equal to that. So I'm going to put everything in my calculator right now. Just how I have given it to you. So 120,000 divided by 2 parentheses and then 1 plus 0.07, close one of the parentheses. Divided by 4 first and then close it. And then that's raised to the 72 power, and then I close all the parentheses. So now it's okay to round because we're at our final answer. So we usually round money to 2 decimal places. So this is how much that the couple will need to put in their account now so that in 18 years they have enough to pay for their child's college. And just one more thing, I made a big deal about how you put it in your calculator and about not rounding, because if you guys round too quickly, you're going to get these wrong in the homework system, because the homework system doesn't round until the very end. So if you start rounding early, especially if you're only rounding to like 1 or 2 decimal places, that's going to be enough to throw your answer off, enough to get it wrong. Another approach to this is that you can put all the decimals you see on your calculator into the expression, but I think it's just as easy to just leave it in its non-estimated form or non-rounded form. Anyway, I hope that helps and that makes sense. That's it for compound interest.